We use series sum, LINEST polynomial in the LINEST polynomial regression of a Maclaurin series expansion, where we have the natural logarithm of ln1 minus x. So ln1 minus x is equal to negative summation of x to the n over n, where n starts from 1 to infinity. So this is equal to negative x minus x squared minus x cubed over 3. So we enter the LINEST for the values of x ranging from negative 0.8 to positive 0.8. So we have RA formula, ln 1 minus x values. So they are all negative except for this portion here. So we will show the chart and regress it to a suitable trend line. The trend line, we cannot use the linear because some data sets are not in some data points are not in the line. So we go by the others. So we have power series, it cannot work. Moving average, it's way out. Logarithmic, it's not good. We'll use exponential, still not good. So we go polynomial. And equation, and the r squared, we can always make this better. Let's increase that to the third degree. 0.998 in the 988. So we better use the third degree, 0.998. It's very close to 1. So we regress it to the third degree in polynomial regression. And we'll calculate these coefficients of B0, B1, B2, and B3. We'll calculate these values of coefficients using LINEST. To do that, we have to fill up the x column and the x squared column and the x cubed column so we can enter the LINEST. So we have RA formula of the x values to the power 1. Here we have RA formula of the x values to the power 2. And this is RA formula of the x values to the power 3. Now we can enter the LINEST. So LINEST data y and data x. So our B0 is 0.02685, rounded up as 0.0269. B1 is negative 0.936488, rounded up as negative 0.936. Our B2 is negative 0.80198, rounded as negative 0.802. And our B3 is negative 0.673. Here it's negative 0.6726666. So it's rounded up to negative 0.673. We can also use the expansion where we have this formula, which is negative x minus x squared over 2 minus x cubed over 3 until negative x to the power n over n. So our values of n will start from 1, incremented by 1. So it's incremented by 1. In this case, we will go to 9. In the coefficients, we'll have 1 over 1, 1 half, and 1/3. So this is equal to RA formula, 1 over the x values. Now that we have the coefficients, we can use series sum to show generate the data set of the expansion, which is equal to RA formula. Because there's a negative sign, we put negative sign series sum of the x values raised to the power, we start with 0. No, not 0, but 1. N equals 1 to infinity. So we start 1 incremented by 1. And the coefficients will be this range. You'll notice the values are almost the same. Let's show this in the chart. So we edit this chart, add this data set, this series. You will notice they fall along the trend line. And we'll also show the trend line equation using polynomial to the third degree because we used the third degree earlier. So show the R squared. So then we calculate the LINEST of data y and data x. In this case, B0 is 0.0226. Yep, it is also 0.0226. Negative 0.9486, rounded up as negative 0.949. Negative 0.76565, rounded up as negative 0.766. And B3 is negative 0.6217, rounded up as 0.622. So this completes the polynomial regression using series sum and LINEST of a Maclaurin series expansion of a natural logarithm ln1 minus x.